Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM exam held in 2025. In this video, we discuss 3 problems and their solutions from the section Real Analysis. And the problems are related to the concepts and the results related to sequences and series. This video is the first part out of the 3 parts. And these questions are suggested for the aspirants of CSIR NET and all set examinations for practice. Right. This is the question number 1 in that question paper, and it is an MCQ for 1 mark. The sum of the infinite series sigma n is equal to 1 to infinity minus 1 to the power of n plus 1 into pi to the power of 2n plus 1 by 2 to the power of 2n plus 1 into 2n factorial in the denominator itself is equal to. We are given 4 options. Right. Let's now discuss the solution of the problem in detail. We are given this series. By seeing this series, what we require to find the sum of the series. By seeing this series, what we remember is this formula. That is the cos x, the expansion of cos x is sigma n is equal to 0 to infinity minus 1 to the power of n into x to the power of 2n by 2n factorial, x belongs to R. Now, here pi to the power of 2n plus 1 by 2 to the power of 2n plus 1, that can be written as pi by 2 whole to the power of 2n plus 1, and sigma is there, 2n factorial is there. So, this is written as sigma n is equal to 1 to infinity minus 1 to the power of n plus 1, pi by 2 to the power of 2n plus 1 by 2n factorial. Right. And from minus 1 to the power of n plus 1, we take out minus 1 and we write it as is equal to minus 1 times pi by 2. From pi by 2 to the power of 2n plus 1 pi by 2 is taken out. And that will be sigma n is equal to 1 to infinity minus 1 to the power of n into pi by 2 to the power of 2n by 2n factorial. The terms are adjusted so that it looks like this. Right. And minus 1 pi by 2 is minus pi by 2 sigma, where this sigma runs from n is equal to 1 to infinity. But I want in the formula the sigma should run from n is equal to 0 to infinity. So, we will start from n is equal to 0 to infinity. That means we have added the first term for n is equal to 0. We subtract. When n is equal to 0, whole of this one is 1. So, we subtract 1. Right. This is equal to minus pi by 2 into this sigma n is equal to 0 to infinity minus 1 to the power of n pi by 2 whole to the power of 2n by 2n factorial is cos pi by 2 minus 1. But cos pi by 2 is 0. So, minus pi by 2 multiplied by 0 minus 1, that minus pi by 2 into minus 1 is pi by 2. Thus, the required sum is pi by 2. Where is the answer? The answer is appearing against option C. Therefore, option C is true. The answer to this question is option C. That is the detailed discussion of the solution of this problem, and it is a very simple problem. Right. This is question number 18 in that question paper. This is for 2 marks. It is an MCQ. The given question is, for n belongs to n, define xn and yn by xn is equal to minus 1 to the power of n into cos 1 by n, and yn is equal to sigma k is equal to 1 to n, 1 by n plus k. Right. Then which one of the following is true? We are given 4 options. So in all these options, what is wanted is whether, see, the series sigma xn converges or not converges, or does not converge or does not converge, and sigma yn converge or does not converge. These are the 2 things what you have to do. So basically you have to discuss the convergence or otherwise of both the series sigma xn and sigma yn. Right. Let's now discuss the solution of the problem in detail. We are given xn minus 1 to the power of n cos 1 by n, and yn is equal to sigma k is equal to 1 to n, 1 by n plus k, n belongs to n. Agreed. Now, we first consider the sequence xn. Now we take, because there is a presence of minus 1 to the power of n is there, the sequence xn can be divided into even indexed subsequence and odd indexed subsequence. So x to n, even indexed subsequence, will be minus 1 to the power of 2n into cos 1 by 2n. So it will be cos 1 by 2n, which tends to 1 as n tends to infinity. Correct. Odd indexed one, x to n minus 1, minus 1 to the power of 2n minus 1 into cos 1 by 2n minus 1. Minus 1 to the power of 2n minus 1 is minus 1 into cos of 1 by 2n minus 1. Now, as n tends to infinity, cos of 1 by 2n minus 1 tends to 1. 1 into minus 1 is minus 1. So, thus the subsequence of even indexed terms converges to 1, and the subsequence of odd indexed terms converge to minus 1. So, they are converging to 2, these 2 subsequences are converging to 2 different limits. Therefore, the sequence is not convergent. And in fact, the limits are different. Therefore, limit n tends to infinity of xn does not exist. So, they are converging to, they are tending to 2 different limits. Therefore, it's not a convergent sequence, and in fact, the limit does not exist. The limit does not exist as n tends to infinity. What is that we want? We consider the series sigma n is equal to 1 to infinity xn. Now, we remember a theorem, that is a necessary condition for the convergence of the sequence n is equal to 1 to infinity xn is that the xn tends to 0 as n tends to infinity. That is, limit n tends to infinity of xn must be equal to 0. That is the necessary condition for the convergence of the series. But here, what we have seen, the limit n tends to xn does not exist. Therefore, this series is not convergent. It does not converge. Assume that this series is convergent, then we must have the limit n tends to xn must be equal to 0. It's a necessary condition. But limit n tends to xn does not exist. So, we remember this one. Right. Because of this one, this does not exist. Therefore, our assumption is not true. Therefore, this series n is equal to 1 to xn does not converge. So, that's the first part is over. Let's go for the second part, that is the yn. Right. We have seen in the first part, sigma n is equal to 1 to infinity xn does not converge. we take in the second case, we have yn is equal to sigma k is equal to 1 to n 1 by n plus k, n belongs to n. We want to discuss the convergence of the series sigma n is equal to 1 to infinity of yn. Right. Now, limit n tends to infinity of yn is limit n tends to infinity of sigma k is equal to 1 to n 1 by n plus k. We remember this can be thought of as a definite integral as a limit of sum. For that we make the necessary adjustments. So that is equal to limit n tends to infinity of sigma k is equal to 1 to n 1 by, take the n common, 1 plus k by n. That is limit n tends to infinity of 1 by n sigma k is equal to 1 to n 1 by 1 plus k by n. Write it as definite integral. That is definite integral 0 to 1 1 by 1 plus x dx. That is equal to after integration ln of 1 plus x to be evaluated between x is equal to 0 to x is equal to 1. For the upper limit ln of 1 plus 1, that is ln of 2. For the lower limit ln of 1 plus 0, that is ln of 1. ln of 1 is 0. So ln of 2, which is not equal to 0, is again the nth term of the sequence. Limit of that is ln2, which is not equal to 0. And when you consider the series sigma yn, and a necessary condition for the convergence of the series is that the nth term must tend to 0. But whereas here the nth term is not tending to 0. Therefore, this series does not converge. So, if you want to make an argument, you can also make an argument, right? And therefore, sigma n is equal to 1 to infinity, yn does not converge. So, thus, sigma n is equal to 1 to infinity xn does not converge, and sigma n is equal to 1 to infinity yn does not converge. Let's look at our options. And our result appears against option D. Therefore, the option D is true. The answer to this question is option D. That is the detailed discussion of this problem. It's also a simple problem. Right. This is question number 19 in that question paper. This is for 2 marks. It is an MCQ. Agreed. The given question is, let x1 is equal to 5 by 2. For n belongs to n, define xn plus 1 is equal to 1 by 5 xn square plus 6. Then which one of the following is true? We are given 4 options. In all these 4 options, you have to decide whether the sequence xn is increasing or decreasing, whether the sequence xn is bounded or not bounded. Right. We now discuss the solution of the problem in detail. We are given x1 is equal to 5 by 2. xn plus 1 is equal to 1 by 5 in brackets xn square plus 6 for all n belongs to n. Clearly, x1 is equal to 5 by 2 greater than 0, positive. xn plus 1 is equal to 1 by 5 xn square plus 6 in brackets. It's also positive. For all n belongs to n. That means each term is positive in the sequence. So xn is greater than 0 for all n belongs to n. This is required for you. Right. Now x2 is, substitute n is equal to 1. x2 is equal to 1 by 5 x1 square plus 6. That is equal to 1 by 5. x1 is 5 by 2. x1 square is 25 by 4 plus 6. Simplify. 1 by 5 into 49 by 4. That is 49 by 20, which is less than 50 by 20. 49 is less than 50, 20, 20. 50 by 20 is 5 by 2. 5 by 2 is x1. So thus what is that you got? x2 less than x1. Now we claim xn plus 1 less than xn for all n belongs to n. By seeing this pattern, we claim this one. We use the principle of mathematical induction to establish this claim. This is true for n is equal to 1. If you take n is equal to 1, x2 less than x1, that is true. Suppose that xk plus 1 less than xk for some k greater than 1. So xk plus 1 less than xk will imply squaring on both sides. Xk plus 1 square less than x square square, xk square. Adding 6 on both sides, the inequality remains the same. Multiply throughout by 1 by 5, the inequality remains the same. And then this will be xk plus 1 plus 1. This is xk plus 2, actually xk plus 1 plus 1. This is less than xk plus 1. So thus the result is true. Xn plus 1 is less than xn is true for n is equal to k plus 1. Now by the principle of mathematical induction, this inequality xn plus 1 less than xn is true for all n belongs to n. Thus, xn plus 1 less than xn for all n belongs to n. For all n belongs to n, xn plus 1 less than xn means it is monotonically, strictly increasing sequence. It is an increasing sequence. Right. We have seen by the principle of mathematical induction, xn plus 1 less than xn for all n belongs to n. This implies the sequence xn is a monotonically decreasing sequence. Agreed? We got one answer. We have to talk about boundedness. Now, xn greater than 0 for all n belongs to n. We have seen. And xn plus 1 less than xn for all n belongs to n. Right? So, therefore, 0 less than, etc., less than xn plus 1, less than xn, less than x1 is equal to 5 by 2. So thus, the sequence is bounded below by 0, bounded above by 5 by 2. So the sequence is both bounded below and bounded above, therefore it's a bounded sequence. Thus what we have, the sequence xn is decreasing sequence and the sequence xn is a bounded sequence. Let's look at our options. Our answer appears against option D. Therefore, the answer, option D is true. Therefore, the answer to this question is option D. That is the detailed discussion of this problem. And in this video, we have discussed three problems. And the first one is only for 1 mark, therefore it will be very, very small. And the next two questions are about, the properties of sequences and series are discussed. And why I am suggesting these previous year questions of JAM examination is this will be a revision for you on sequence and series, number one. Number two is, at times, the questions that have appeared in JAM are appearing again in CSIR net examination. Sometimes these questions are made strong by adding some more things in it, and they are giving. That's the reason why I am suggesting these problems that you have to learn, and by the time that you are doing sequence series, you also revise your knowledge of sequence series. That will be an opportunity. Right. I am sure that you have understood the solutions of these three problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.